All right, in this example, or in this graph, we can see that the limit as we approach -1, as x approaches -1, as we come in from the left or the right, it looks like the y value is going to 2. So we can see intuitively that that's what the limit is. But now let's take a look at this from an epsilon delta point of view. Given that epsilon is 1, so epsilon, remember, that's the interval, the epsilon interval on the y-axis. Find the biggest value of delta, that's the interval on the x-axis, such that when we subtract 2 from f of x, take the absolute value, it's going to be less than some positive number epsilon. It'll be in that epsilon interval. Whenever the distance between x and -1, x minus a -1 is x plus 1, whenever that distance, absolute value, is less than some value of delta. So what do we do here? Epsilon is 1, so we start at our limit 2. Here's our limit. Epsilon is 1, so we go up 1 and down 1. So this here is our epsilon interval. Now, go to your graph, starting at epsilon, at your limit plus 1 at the top. Go to your graph and down. That lands us right there at 2. Then do the same for our limit -1. L minus 1 is 2 minus 1. That's down here. Go to your function and down to the x-axis, and that lands us at -2. Now, keep in mind that we're approaching -1 right here. That's where we're approaching. It's a limit. And look at the distance on the left side of the limit. That distance is 1. Look at the distance on the right side. That distance is 3. And what we actually do, the biggest value of delta is going to be the smaller of those two distances. I'll explain why in just a minute. Clearly, 1 is smaller than 3, so 1 is the biggest value for delta. So that means as we approach -1, the distance away from -1 can be no bigger than 1. 1 to the left takes us to here. 1 to the right takes us to here. So this is our delta interval. And as long as we're in that interval, when we go to our function and over, it will land us in the epsilon neighborhood, as long as we don't get outside that interval. Notice if we get outside that interval, let's say 1.5 to the left. Well, when I go up to my graph and over, this is not inside my epsilon neighborhood anymore. So when I start picking numbers bigger than 1 for delta, then all those values will not land us in the epsilon neighborhood when we go up and over. But as long as delta is no bigger than 1, we're no further than 1 away from -1, when we go up to our function and over to the y-axis, we will be in that epsilon neighborhood. So therefore, for this problem, the maximum value of delta is 1.